What if you could write knowledge-based rules just by describing what you want? This video shows an AI chat application, built into Design++, that turns plain language into working 3D model rules. The integrated AI assistant knows your class hierarchy, follows your syntax, and participates in the generate, test, refine loop your engineers already use. This demonstration uses 3 applications. Design++ is the design automation platform that drives the modeling work. It interprets engineering rules and uses them to generate 3D models in CAD. The AI chat assistant is a new capability integrated into Design++ that helps you write those rules through plain language conversation. CAD is where the resulting models appear. Design++ executes every user-approved function or rule AI suggests. We start with a simple model, a tabletop and 4 legs. The first enhancement was adding a support frame composed of rectangular rails modeled as boxes. We asked AI, how should we add a support frame assembly and support rail components using documented Design++ functions? When you submit a prompt and press apply, the AI chat sends its result, a function or a rule, to Design++. To process our prompt, AI analyzed the uploaded documentation and suggested the appropriate library functions for creating a new assembly class and adding a rail components class. AI also defined geometric rules and rules for positioning the rails relative to the legs. With the new classes in place and the AI-generated rules applied, we now have a working support frame. Next, we introduced a support type attribute. This allows rectangular or round tops with either legs or a pedestal support, independently of the top type. We asked AI to write a new substructure rule, the logic that defines how parts fit together, that combines both attributes so any top shape can pair with any support style. With AI's help in authoring the new attributes and rules, Design++ lets us explore design configurations quickly without manually rewriting large portions of the library. With the frame in place, a problem becomes visible. The rails and legs were positioned assuming a rectangular top. When the top type is changed to round, the geometry updates, but the legs and rails stay anchored to rectangular assumptions. To fix this, we ask AI, what if we compute a legs bounding box attribute for the support frame assembly and then use that to both place the legs and support rails? The rules were correct, they just weren't abstract enough. AI proposed a parametric boundary whose rule computes dimensions based on whether the top is rectangular or round. The legs and rails derive positions from that attribute rather than from just the rectangular values. Now, switching to round recalculates the bounding box and the legs and rails follow automatically. At this point, the length of the rails is still tied to the width and length values for a rectangular top. We asked AI, would you please update the support rail geo width rule to use the support frame legs bounding box value? After a few iterations, we now have a rule for the length of the support rails that works for both rectangular and round top types. This is AI assisting in architectural refactoring, not just adding code, but restructuring design logic. The final enhancement was the most demanding. We asked AI, how can we convert the support rails from simple boxes into mitered rails? This required changing the support rail geotype from box to width depth, implementing a geoprofile rule, adjusting geometry calculations, managing orientation, and corner alignment. It was not a single prompt and a perfect result. AI generated an initial approach. We tested it, identified where the geometry needed correction, and described the problem back to AI in plain language. AI revised the approach, and we tested again. That loop, generate, test, refine, is how real engineering work happens. Here is how AI transforms Design++ application development. Accelerates development by acting as a smart assistant that understands the full project context, whether starting from scratch or extending an existing application. Lowers the learning curve and accelerates onboarding by enabling development through natural language prompts and serving as an always available tutor, removing the need for deep, upfront mastery before becoming productive. Bridges the gap between domain experts and developers by allowing engineers and subject matter experts to contribute design rules and logic directly without relying on specialized Design++ programmers. Helps you understand and debug applications by reading the project, explaining how rules and components behave, and identifying why a model is not producing expected results. The human expert directs, AI accelerates. If you're looking for a sustainable competitive advantage through the automatic reuse of engineering knowledge, then Design++ was built for you. To explore real-world applications and learn how design automation can work for your team, visit us at designpower.com. Thank you for watching.